Welcome to a video on Chapter 1, Section 7. We're going to talk about midpoints and distances. We're going to look at things on a number line, so kind of one dimension, and also on the coordinate plane, which would be 2 dimensions. So we start off just with some formulas. On a number line, if we are given 2 coordinates and we want to find the midpoint, basically we're going to find the average of the 2 values. And I think to a certain degree that makes sense. If I have something here and something there, and I want to figure out what's right in the middle, kind of figuring out the average is going to get us right in the middle. If I have 2 test scores, let's say, and I want to figure out the average, you just add them together, divide by 2. That's basically what you're doing when you find the midpoint on a number line. On the coordinate plane, it's very closely related. It's a little bit more complicated. You can see in the picture it's got more stuff to it. But on a coordinate plane, the points have 2 values, right? An x value and a y value. So we have our 2 points there. And if I want to figure out the point, if this is point A and this is point B, and I want to figure out what's right in the middle, I'm going to find the average of both. So one x value is kind of measured right here, the other x value might be measured right there. In between is right there, and that's the x value for the midpoint of that segment. Same thing for the y values. If this is our first y value down there, and that's our second y value up there, we want to figure out what's right in the middle, and that's going to get us to our midpoint right there. So think average all the time on this front page of notes. So if we go to some of our examples here, the first one says AB has an endpoint at -4 and at 9. We want to find the midpoint of that segment. You see the picture to the right. And you can kind of tell the middle is going to be somewhere around here. Whoops, I don't have my highlighter on. Somewhere around here. We just need to figure out exactly where. And you see that the number line goes up by 2, so that makes it a little bit more difficult to figure this out as well. But according to our formula, we're going to take the 2 numbers, so -4 and 9, and just add them together and divide by 2. So that gets us -4 plus 9 gets us a positive 5 over 2, so 2.5. That is our midpoint, and you can see, I think, that it kind of matches up with what you would see on the picture there. So if we look at our second example, now we're on the coordinate plane. It says that segment EF has endpoints 7, 5, so that is way up here, and then also at 2, -4, that's right down there. The midpoint is going to be somewhere in this general area, and to find that actual midpoint, we just need to take the average of both. So let's start with the x value. So we have a 7, and we have a 2. We're going to take the average, so we divide by 2. That gets us, 9 over 2, which is 4.5. Okay, and then we would do the same thing for the y values. So that is 5 plus a -4, or really 5 minus 4, divided by 2. And that's 1 over 2, or 0.5. So where's that on the graph? It's a little hard to see because I think the y-axis is not showing up too well there, but there's the y-axis right there. So if we were to go over 4, 1, 2, 3, 4, 0.5, and up 0.5, the midpoint's going to be somewhere right around there. That does seem to make sense in our picture. So our last example involving midpoints just kind of makes us think about it in a slightly different way. Here they're going to tell us the midpoint. The midpoint of segment CD is -2, 1. You see that as an M on your picture. They give us one endpoint, point C, and we're trying to find the other endpoint. So they tell us that the endpoint is -5, 7. So if we knew the endpoints, we would take the average of x, and that would give us the x value of the midpoint. Now we just have to kind of set it up, but we know different pieces. So I know one of the values, which is -5. Whoops, let me get my pen. Okay, so I know -5, but I don't know the other one. So let's say that this other endpoint was over here. We'll just call it x, y for right now. I would have to add that. It's an x right there. I'd have to add that to the -5 and divide by 2, and that would give me the midpoint of this other piece. Well, in this case, I just don't know what the second x value is, but I do know the x value of the midpoint, and that was -2. So I've just put in the pieces of what I know into the right spot, and now I have to think of how I would work backwards and solve that. So in this case, algebraically, I would want to get rid of that 2 in the denominator, so I'm going to multiply this side by a 2, which means I multiply this side by a 2. So this kind of cancels off with that. Okay, so I would have, let me go back to black here, I'd have -5 plus x equals -4. Okay, and then I would add 5 to both sides. Add 5 to both sides, and I get x equals 1. So at this point, what I know is that the x value of this endpoint is 1, and I'm still looking for the y value. Okay, so let's do the same thing, but with y. So let me create just a little bit more space here if possible. There we go. We'll set it up in black again. They tell me that the, let's see here, the y value that I know for the endpoint was 7. So I'd have 7 plus whatever the other y value endpoint was, and then I divide by 2. That gets me the coordinates of the midpoint, and the y value for that was +1. So you really have to look carefully. If you're not paying attention to the actual question, now all of a sudden I'm just writing all this stuff down. You need to go into the question. You need to look at it and figure out where that 7 came from, where the 1 came from. They're all y values. The fact that I'm trying to find a y value of the endpoint, and that's normally what we would put right here, and then our formula says divide by 2. So you have to do a little thinking as we go through this. Okay, then go through the same process. I want to solve for the y, so I'm going to multiply this side by 2, multiply this side by 2. Okay, this cancels off, and I'm left with 7 plus y equals 2. I need to subtract 7, and so in the end that gets me y equals -5. Okay, so I go back up to this. Oh, some of that writing kind of stays there. But that's telling me that my other coordinate would be 7, comma, let's see, we came up with -5 there. Let's go back to my pen here, 7, -5. Okay, and that does seem to make sense based on this point right there to say that it's 1, comma, -5. That seems to work. Okay, so that's what we know about midpoints. On the back page, we're going to talk a little bit about distances. And let's see here. Let me move this just a little bit. Yep, there we go. Okay, so just a little review. We've talked about distance already in an earlier lesson in this chapter. So we're just going to quickly review it. Again, one dimension on a number line. We have coordinate A. The coordinate of point A is 3, and the coordinate of point B is 12. What's going to be the length of segment AB? That's what this notation right here means. Okay, what's the length of AB? You could certainly draw a picture and kind of type it out. I think intuitively you realize that it should be 9, but really what I want you to take away, just a quick reminder that if this is the first coordinate and that's the second coordinate, this idea of absolute value gets us the total distance. Yeah, so that's what I really want you to remember here. So I could have, for this particular question, I could have gone 12 minus 3 in absolute value, which gets me 9 in absolute value, which is just 9. Okay, I realize it's pretty simple. You could have just gone 12 minus 3 right away with no absolute value. But I think it's important that we know we could also have gone 3 minus 12 within absolute value, which gets us the absolute value of -9, which is +9. Okay, so that's what we know already. Now we're going to try and apply this to more of a two-dimensional idea. Okay, so that's what the formula is up here. We have this distance formula. You may have noticed this or seen this in Algebra 1. If we have 2 points, so 2 combinations of xy values or xy pairs, we plug the x's in this spot in the formula. So subtract them and square them. And then we do the same thing with y, subtract and square. Whatever we get from that, we add together and then take the square root. The nice thing about this particular formula, you're not going to mess anything up if you accidentally mix the x's together or the y's together. So here it says if you start with the second x value, you better put the second y value first. Just the way the math works out here, if you happen to put the second x value first and then the first y value first there, it's going to work out okay. So that's a nice thing about this, but we do kind of like to try to keep it somewhat organized. So this is all based on Pythagorean theorem. We're trying to find the distance from here to here. And if I know this and I know that, that's a relationship of a squared plus b squared equals c squared. While this bottom part of the triangle on a coordinate plane is just the difference of the x values, and this kind of vertical piece right there, that distance is the difference of y values. So another way of maybe writing this statement here is if I were to get rid of that square root, that means I square both sides. I'd have to square the distance part, and then here I would just have x sub 2 minus x sub 1 being squared plus y sub 2 minus y sub 1. That's supposed to be a y sub 1 right there being squared. And that gets us into Pythagorean theorem. This would be the c squared part. This is kind of like a squared, and all this is like b squared. So that's where it comes from. Do you need to be able to prove that really, really well? No, probably not. But I hope that intuitively it kind of makes sense, and if not, please ask some questions about it in class. So let's quick wrap this up. We'll look at our last example here. It says, what's the distance between 2 points on a coordinate plane? We know the coordinates there. It's just a matter of plugging it into the equation or into the formula. So the distance is going to equal the square root of, we got a really big one to start off. We're going to go x minus x. So I might go 4 minus a negative 7, and I have to square that. Okay, and then I'm going to add to that the y value stuff. So since I started with 4 for x, I'm going to start with negative 3 for y. But again, like I said, if you happen to mix it up at that stage, it's not going to cause any major issues. It does work out okay for this particular piece. Other places, though, that would cause some issues. I think of like slope as an example. Okay, so what do we get from this? 4 minus 7 is really 4 plus 7, so that's 11. So we're going to have the square root of 11 squared. And then negative 3 minus 5 is really negative 8. So we're going to add to that negative 8 being squared. Okay, so that's going to be 11 squared is 121, and 8 squared is 64. So 121 plus 64. Okay, all of that together is a total of 185. So square root of 185. Okay, that's not the necessarily the nicest value ever. We would need to put this into like a square root sort of thing, but in the end we're going to get about 13.601, and that's going to be our answer. Okay, we'll stop there. Let me know if you have questions.